Hey everybody, little video. This is our worksheet for tomorrow. I'm kind of limited, but would have liked to have done this at school. But anyway, let's get started. We got this function here. You're going to put in your graphing calculator x cubed plus 6x squared. Okay, it's going to be a cubic function that's going to kind of go up, down, and up. Okay, it's going to look very similar to this, but just going to be flipped over. This is a negative cubic function. So we're going to have the up, down, and back up, okay? And we're going to have these transformations that we're going to do to maybe move things around. Okay, let's go to this one first. F absolute value of x. What that means is everything I put is in positive, okay? So we saw an example of that here, where this is the absolute value, the square root of the absolute value. Notice when you, inside your function, if you have an absolute value, it basically reflects this graph over here. Both sides of the y-axis will look identical because these inputs, since -1, you're going to take all these negative values, you take the absolute value of, and so they end up being positive, just like here. So this graph on the right is exactly the same graph. It's mirrored on the left. They could be, okay? It's just a reflection, okay? So that's what happens when you do this right here, okay? Everything's positive, so the left half, to the left of the y-axis looks just like the right. Now this is the absolute value of the output, okay? This will take graphs like, let's take this graph. Anything negative becomes positive. I mean, we're taking the absolute value of the output. So this graph will come down, go up. This whole negative portion is flipped over the x-axis because now we take the absolute value of all these values. It'll go like so. This stays the same, and this whole part here, but anything below the y-axis is flipped up, okay? All right? So this graph, the left of the y-axis is identical to the right of the y-axis, okay? Everything below the x-axis is flipped up. This right here, this will cause a reflection across the y-axis, okay? All right, so let's take a look at maybe something everything you plug in, and we're gonna take the negative value of, okay? So let's look at a graph, okay? So this graph here is gonna reflect over here because when I plug this in, I'm gonna get and this graph here is going to reflect over here. Everything is going to flip across here because when you plug in 1, you're really going to take f of -1, which is this value. F of 2, I'm going to get this value. All these, I'm plugging these positive numbers, but I'm taking the negative numbers, right? Because we're doing, remember what we're doing here. I plug in an x and we take the negative value opposite, okay? So hopefully you can see my little cursor, but so this causes this graph will flip over here and this graph flips over here. It causes everything to flip across the y-axis because instead of taking these positive values, we plug in positive, we get we put a negative in front of them, we get the values that normally you get here. And here, all these negative values, that negative changes the sign to be positive and we get the positive value. So anytime all these graphs would just flip over the y-axis, okay? Because you're taking the opposite value of x, okay? Let's go back. This right here flips everything across the y-axis, okay? You take all your outputs, and here I'm changing the input. Before I I'm putting a negative on things and taking the opposite. Here this changes the output. Notice it's outside the parentheses, okay? All right, so I can flip something, okay? This is a vertical shift. I'll take any one of these graphs and then shift it up. If I wanted to create, let's say, only one, right now I've got zeros or roots, x-intercepts here, here, and here. If I shift this up about, 2, 4, 6, about 6, this graph's going to be way up here, and I'm only going to have one x-intercept by shifting this up. So we can change graphs, okay? I can horizontally shift this graph and maybe put this minimum over here or here, and it will do that. Okay, this is a vertical shift. This is my horizontal shift, okay? I can choose that, make that relative minimum occur over a different point. Remember, minus goes right, plus goes left. It's in the parentheses is horizontal. Outside the parentheses is vertical, and plus and minus are always shifts. Okay, let's look at this a times f of x. This will be me stretching the graph, not shifting it. Okay, all my outputs are multiplied or stretched up and down if it's negative. But this will either, if this is the horizontal compression or stretch, okay? Sorry, my phone went off. Okay, so let's go back to inside the parentheses is horizontal, okay? If I wanted to squeeze this in, I'd multiply this function inside the parentheses by a greater than 1, and this would be tighter. If I wanted to stretch it out, we multiply it by a fraction, okay, inside the parentheses. That would be horizontal stretch or compression, okay? If I wanted to vertically do this, I'll vertically stretch it or compress it. A fraction, these are backwards. A fraction compresses this vertically, a fraction here stretches it horizontally. Integer greater than, or I'm sorry, a number greater than 1 will vertically stretch this, where a number greater than here vertically, or horizontal, a number greater than 1 here, b greater than 1 compresses this horizontally. If a is greater than 1, it stretches. So if I wanted to like take this point and pull it down, keep that 0 where it is, make these points come up, that'd be multiplying a times f of x, okay? A times f of x where a is greater than 1, all right? If I wanted to make this point come up, make this shallower, 0 stays there, and shallower, I'm multiplying all my outputs by a fraction, where like a times f of x, where a is a fraction, okay? If I wanted to move this in, keep the values kind of, but move everything in, that would be the compression right here, b times x. Okay, plug in an x value, we multiply it by something greater than 1, we'll compress it horizontally compress it. If b is a fraction, it'll stretch it horizontally, okay? So you'll look at this problem and we can move things around, move this relative max by shifting it maybe. We can flip things with this, flip it over the x-axis, flip my y values, flip it over the x-axis. Flip my values across the y-axis, make everything positive, and make everything that's normally negative flips over the x-axis, becomes positive, and here, like I said, the left of the y-axis is identical to the right of the y-axis, okay? That would be like we saw here, right here. This is the function, absolute value of the function. The function was the square root. Square root of the absolute value of x. Notice how everything's positive, and so is this, so these graphs are the same. And hopefully that'll help you out for tomorrow. Okay, let's take 9 minutes, gotta go. Okay, we'll see you tomorrow. I'll be next door, but won't be in class because of an Petroleum Academy function. Okay, take care.